Welcome to the introduction to Docker. We'll be talking a lot about Docker. Containers have obviously been very big in the past few years, and even more so going forward, we'll see a huge migration of things running in a virtual machine, migrating into running into multiple containers. And this is the way most applications, server applications, are moving towards. But to really understand how containers work, we need to first understand how virtualization works. So most of us are familiar with virtualization of one form or another. In data centers, by far, the VMware is the dominant in most commercial data centers. However, Linux KVM, Linux Kernel Virtual Machine, is rapidly gaining traction in a lot of spaces, as well as Hyper-V by Microsoft. The reason being is VMware has significantly more features than their competitors, but people really just want the basics. What do they want in their data center with virtualization? Well, they want virtualization, being able to run multiple servers on a single physical box. They want vMotion, the ability to move one of those virtual servers from one physical host to another physical host without having to shut it down. And they want high availability. If a virtual machine or a physical server fails, they want the virtual machines that were running on that physical server to automatically start somewhere else. And so we've really seen kind of a leveling of the play field. Why did VMware get such a start in this? Well, it comes down, people think VMware invented virtualization. No, virtualization was around for a long time before VMware. What VMware did do was virtualize the Intel x86 platform, the x86 processor, and patented the bejesus out of it. And so it made it very difficult for people to enter the market with those patents in place. So first patents came out like in 98, the product came out in 99. And, it was huge. The virtualization of being able to run multiple operating systems on a single box was massive, but really something called vMotion was really important because I could move a running virtual machine from one host to another. Say, for example, I needed to go ahead and upgrade the memory in a server. Well, in the old days, I would have to schedule downtime, right? With virtualization, I could simply take the virtual machines that are running in the server that needs maintenance, move them to a server that is running, and take all the virtual machines off the one that needs maintenance, all right, without stopping those machines, do the maintenance, bring the server back up, and move the workload back. That was really huge. And so VMware became, super dominant. But let's talk about virtualization. What are we virtualizing? We're virtualizing the hardware. And that's kind of an important thing to remember is this is hardware virtualization. Every virtual machine thinks it has its own hardware, right? So each of these guest operating systems think they have their own hardware. And so they go ahead, they have virtual drivers to talk to the network, to the storage, to the compute. All these things are virtualized. And so we're virtualizing the x86 platform. This allows us to run all kinds of operating systems, right? I can run Windows, Linux, any x86 operating system that is out there, I can go ahead and I can run on it. And so this was kind of cool. But when you think about it, every virtual machine, every time, say we want to run a server with some applications on it, when we spin up a virtual machine, we have to spin up the guest operating system for that virtual machine. So as you imagine, say I wanted to run 50 separate web servers. Well, what would I have to do? Create 50 virtual machines, install a guest operating system on each of those 50. So if I'm doing Linux and I have 50 virtual machines to run this application, that means the Linux operating system is running 50 times. All right, not very efficient, and we'll see if we have some solutions to that. So what's some of the big things here? Remember at this time what was happening is when virtualization really became popular is the CPUs were getting super duper powerful, right? We had multi-threaded CPUs, lots of different cores, all this kind of cool stuff, and more memory. And so we had a lot of physical servers that were only using a small percentage of their resources. With virtualization, they could now put multiple workloads on that same physical server and made it much more efficient. Really helped us to reduce capital cost, buying the hardware, and operating costs because it's easier to manage virtual environments. We already talked about the maintenance, failover, all that stuff was so much easier with these portable workloads. And the big thing, of course, is it saved money. All right. What were some of the disadvantages? Well, there are some disadvantages to this as well. Oversubscription can be a disadvantage. What do we do? Well, say, for example, I have, a 100 gigs of RAM. All right, I have 100 gigs of RAM, and I create virtual machines, all right, that take up 25 gig. Well, I might go ahead and create 5 of those. So in other words, I'm saying, hey, listen, these 5 virtual machines are going to use 125 gig, even though the physical machine only has 100 gig. And what that's doing and what we're trying to do, there's oversubscription. Why? Because it's unlikely that all 5 virtual machines are going to need all 25 gig at once. All right. But we had ways to control it with ways we could limit our resources. We could do limits, we could do shares, we could do reservations. There's lots of cool ways. So that was something. Do they run as fast as being on bare metal? No, the operating system doesn't run that fast because we're going through an abstraction layer. All right. You'll see the percentages debated out there. Typical numbers I see around 4 or 5%. Boot up time, well, every time you want to start an application in a new virtual machine, you have to go ahead and you have to launch the operating system. Just think about it. If you wanted to run Notepad, right, on your laptop, what do you have to do? Well, you have to turn on your laptop, wait for it to boot up, and then double click. Actually, starting Notepad doesn't take long. It's going through that power on self-test and booting the operating system takes a while. And the other kind of challenge we have with virtual machines is if I have 50 identical virtual machines, they each have their own hard drive, right? They each take up, if each of them takes up 5 gigs of disk space, that's going to go ahead and multiply by the number of virtual machines. Containers address a lot of these, all right? So when we think about a container, what are we abstracting? We're abstracting the kernel of the operating system, that Linux operating system kernel, all right? So instead of being hardware virtualization, this is operating system virtualization. And so we load up that kernel once, that operating system once, and then the containers share that operating system kernel, all right? And so basically that kernel is running all the time, so we go to start an application, it's very fast because we're abstracting here, right, at this operating system level. And so when I go to spin up an application, it's like you already had your Windows machine running and you double click on the application. You have to wait for that operating system to boot. So we'll see that containers come online much, much faster. Now the very first time you run a container, if it's not locally on that hard disk, you're going to need, of course, to go ahead and get the container. And so that will be part of the process. But let's think about this. If I want to run 50 web servers and 50 containers, how many times is that Linux kernel loaded? Just once. Huge advantage. And so what we'll see is environments like that, oftentimes a server can run 10 times as many containers as it can if they were virtual machines. So containers have been around for a very long time, or at least the concept of them. If we go way back in 1979, Unix, there was something called chroot, which allowed us to go ahead and kind of create isolated disk space for different processes. That eventually got added to BSD, and then decades later, around 2000, something called jails came out. This was FreeBSD jails. And this was a big deal because it isolated file system using and networking. So that means each jail could have its own networking. And that was huge, right? Well, Solaris Containers came out about 4 years later. And this came out for x86 as well as the Spark. Those of you old enough to remember the Spark boxes. And so this was kind of neat. And they had different types of zones that they're able to go ahead and create isolation and create kind of these containers. But really, there was a couple of things between those two that aren't on the screen here, which is they had control groups came out in Linux. And so with control groups or C groups, this allowed us to go ahead and really create and control some of the resources in there. And then around 2008, Linux Containers came out, LXC. But it was really in 2013 Docker. So Docker is the most popular one out there, right? This is the most widely used container management system currently. And so this was huge. It was a very efficient way to deploy applications, right, to have different types of model, to have this whole different types of registries for containers. And we'll get into that. Had a nice API, easy to use CLI, and even later on, we were able to manage clusters of Docker servers. There's a couple others that should be mentioned here. Rocket. Rocket was basically introduced to address some of the shortcomings of Docker, particularly on the security side. And so basically, we go ahead and in addition, they have a lot of rigorous security and requirements than Docker. So it's a little bit more hardcore than Docker. LXD came out with Canonical, and it's another thing. It's more like virtual machines, all right, and kind of give that virtual machine look and feel, but it's with containers. And of course, Windows. Windows 2016, 2019, as well as even certain versions of Windows 10, have Windows containers. So Microsoft started adding containers to their operating system, and it runs great, or it's very cool. And so you can go ahead with this, and you'd be able to go ahead. There's ways to run Docker containers on Windows machines, which is very cool, as well as Windows' own specification for containers. And the idea, of course, especially with things like Azure, is to be able to migrate that Windows workload from your desktop to your data center to the cloud. So let's think of some of the advantages. Containers have a number of advantages, or we wouldn't be talking about them. And so first of all, consistency. It's very frustrating, especially for a developer. They'll create an application and it runs on their desktop, but when they go to run in the data center, it doesn't run. It's missing some dependency, it's missing some resources. Well, the environmental consistency is huge here, right? So we get consistent. It's going to run everywhere because it includes all the resources necessary to run. They're also very efficient because we're not running tons of instances of the operating system. So it allows us to go ahead, and it's very easy to scale containers. They boot up fast, all right? And we're going to see, you can go ahead and you can easily increase and decrease the number of containers based on the need. We start looking productivity-wise. We take these big, massive applications, we break them down into smaller applications. And then finally, we have some version control. The version control here is very cool. It makes it easy not only to deploy new versions, but even to roll back to old versions. And we have some very kind of cool rolling updates that we can do in the container world. So Docker is exciting. It is definitely going to become part of your life if you're a network engineer or a developer. You will be using containers. And so just kind of keep an eye out as you see new technologies of all like AI and stuff like that. It's all container based, right? All the new stuff is being container based. So this is our introduction into our Docker environment.